Hey guys, Mr. Roden here. Hope you guys are having a good day. And I'm just wanting to talk about 5.1 out of the Red Book. I know we've done a 5.1 before, but we're going to do 5.1 out of the Red Book because the Red Book kind of has some topics that weren't covered in the Blue Book that you guys normally use. So first of all, let me go. Our agenda is pretty simple. Our learning target is I can identify two figures that are similar and use the rules of similarity to find parts of the figure. And then the second thing I want to do, so my agenda is good thing and 5.1 Red Book. So my good thing today is that last week I did, everyone was at home. We were all doing remote learning, and I felt like it was pretty successful. Felt like it was still able to teach a lot of new content, and it seems like attendance was really good with my students, and students were engaged and showing me their notes, and so it was really I felt like it was successful, a successful week of remote learning. We didn't have to miss a step, or so I was happy with that. So that's my good thing. All right, so let's take a look at what this lesson here now. Before we get started today, I want to kind of just show you a couple things here. So let's say that I'm going to go ahead and let me give myself a little bit more room here because I don't want this problem to be in the way. Let's say that I have a shape, okay? And I put this shape up here, okay? Just a good old-fashioned triangle. And I'm just going to go click on this triangle right here, and I'm going to copy it. And then over here, I'm going to paste it. Okay. So what I have is I have duplicates of the exact same triangle. Now, just to show you that I'll just make one red and I'll make this one red so you can kind of see it. So these two triangles are what we call congruent. Now, the way you can think of congruent is I have one of my students say duplicates. They're duplicates of each other, right? So if I come over here and I take this triangle right here, if I take this red triangle right here, if I take this just want the red triangle, and it will line exactly up. All the corners line up and the sides exactly line up. So you can't even really see the other one when I put the red one on top of it. You can a little bit, but you shouldn't. So that's called congruence, okay? Congruent figures are everything is congruent. So all the matching sides and angles are congruent to each other. Now, if I take this red triangle right here and I kind of take one of the corners, you got to do it at one of the corners, you can't do it, and I just shrink it. Now, obviously, they are not congruent anymore, are they? See that? See how they're not congruent anymore? And I may have talked about this with my class before, but it's a good review. But there is a relationship here, okay? There is a relationship here. So this triangle is not congruent, but it's similar. And the key about being similar is, do you see how those corners line up right there? And then I can take this angle up here. All three angles are exactly the same. It's like a puzzle. It fits perfectly into its angles. So these two triangles are not congruent. They are similar. So if I wanted to write this out, let's say that this is angle A, and this is angle B, and this is angle C, and let's call this angle D, E, and F. And so there's two ways I can say this. I can say that triangle ABC. Now look what I'm doing. So when I name a triangle, A lines up with D, B lines up with E, and C lines up with F. So I want to name it in that order. So if I go yellow, green, purple, I need to do yellow, green, purple on the other triangle. So there's two ways I can say it. I can say it in words. So triangle A, B, C is similar to triangle D, E, F. Now, And we have a little symbol for that. In my class, we learned, this is just a little bit of a review, ABC is similar to triangle DEF. Those are similar triangles, okay? Now, and like I said, this is a little bit of a review, but when you're naming this triangle, see how we had to be really careful how we name these triangles. We can't just willy-nilly start picking letters from each one. A comes first here, D comes first in that one. Okay, B comes second here, E comes second here in that one. And then we can say C comes last, but F comes last. So remember, when you name a triangle and they're similar to each other, you have to be consistent. You have to put their what we call their corresponding or matching angles in order. All right. So if I wanted to do this, so let's say I know these two triangles are similar. And how do I know they're similar? Because of this symbol right here is telling me they're similar. So what I'm going to do is I'm going to match up all the corresponding sides, all the corresponding angles. Okay, so what angle X, what angle corresponds, and they're going to be congruent to each other. So I'm going to use we'll just say equal. These angles are going to be equal to each other. Their measures are going to be equal. So what angle is X equal to? Well, yeah, angle Q. And these are angle symbols. Okay, this is an angle symbol. Okay, all right. What angle matches up with angle Z? Well, so let me do the highlighting here. I think the highlighting can help us see this a little bit. So X and Q. Okay, so now we're going to choose angle Z. What corresponds with angle Z? Well, yeah, angle R. So now we could say angle Z is equal to angle R. And then the last one we could say is H. So maybe we'll go yellow on this one. So Y and H, right? So because remember, Y and H come last in this statement right here. So now we can say that angle Y is equal to, the measure of angle Y is equal to the measure of angle H. Okay? So what I want you to do right now is, so I just lined up all, I lined up all three pairs of corresponding equal measured angles. So what I want you to do right now is I want you to do the same thing here. Now notice it's turned, so you have to be very careful. So your job is to tell me all these angles that are the three pairs. No, in this case it's going to be four because it's a rectangle. Give me the four pairs of congruent angles. Pause the video and go ahead and figure that out for me. Hey, welcome back. So, and if you haven't done it, make sure you pause the video. Okay, so notice I don't know which way this rectangle got turned, right? I don't know if they turned it to the right or turned it to the left or flipped it. Who knows what they've done? So I can't really go by the picture. I have to go by the similarity statement. So the first thing is I have an A and then H. And then I want to go B and I. And then I want to go, let's see here, C and J. And then I want to go D and K. So I'm going to go ahead and line these up here so I know that angle A, the measure of angle A, is equal to the measure of angle H. Now, since it's a rectangle, all the angles are going to be equal to each other because their rectangle means 90 degrees, okay? So technically they're all equal to each other. So if this wasn't a rectangle, I'd have to be a little more picky. But it's good practice kind of lining up the equal angles. And then I could say angle B is equal to angle I. And then I could say angle C, the measure of angle C is equal to the measure of J. And then I could say the measure of D is equal to the measure of K. I'm just lining up the angles that correspond from this statement here. So this is good practice, just looking at this one and looking at this one, and then lining up the angles that are equal to each other. Remember, these are not congruent. They're not congruent to each other. They're similar. Okay, one is absolutely bigger than the other, but they're similar. Okay. All right, so your job right now is to go ahead and fill in. So I want you to draw this out, and then I want you to fill in all the angles, the missing angles in this. I want you to fill in all the missing angles in this shape right here. Okay, so fill in all the missing angles in this shape. You should have, we got 4 of them. Okay, go ahead and do that right now. Pause the video and fill the missing angles in. Okay, welcome back. So we could do it 2 different ways. We could look at the picture, because it doesn't look like the picture it looks like they're going in the same direction, but maybe not. Maybe it's been flipped. So angle U and L. So if U is 32, since they are similar, their angles have to be equal, their measure, so that has to be 32 degrees also. R is 167. So this is so easy. See that? And then R is 167. So R and M correspond to each other. S is 29. So N and S correspond with each other. So this is 29 here. And then T is 132 here. So O, T and O correspond to each other. So that has to be 132 right here. And we're done. How did you do? Pretty easy stuff, right? So this is a little bit of a review. I think we've talked about this in our in prior classes. So let's get to something that may be a little new for you. First of all, I want to talk about something called indirect measurement. Okay. Now, what is indirect measurement? If I have, there's different ways you can measure things. So let's say I'm standing outside. Okay. Let's say I'm standing outside. And let's say that the sun is shining on me right here. All right. Now, when you stand outside and the sun is shining on you, you're going to get something called a shadow. So let's say this is my shadow right here. Okay? No, I'll make it straight here. And let's say I'm standing like that. There's me. So there's me and my shadow. Now, at the same time, maybe there's a flagpole right here. Okay? Sorry, no, not a great artist here. And let's say there's a flagpole right here. Now, it's also going to have a shadow. Now, let's say I wanted to measure the flagpole. Now, this would just be dark, right? You wouldn't see all that, and then you wouldn't see all this. This is just dark. It's my shadow. So let's say I wanted to measure the flagpole. Now, there's a couple things I could do. So first of all, I could just get a measuring tape, right? And I could measure myself, or I could stand up against the wall and mark my thing, and I could measure that. And then maybe if I had a friend, they could measure my shadow. This could be hard right away, but maybe they could measure my shadow. So maybe me and a friend does this, and I could measure myself, and then if I wanted to measure all these things, okay, I could measure my shadow. I could measure the shadow of the flagpole. That's easy, just on the ground, right? Here's the problem, though. Flagpoles are usually tall. So I don't know if you want to shimmy jimmy up the flagpole, or this would be a hard one to measure, right? Because it's hard to measure flagpoles. It's hard to climb up flagpoles and see how tall they are. Okay, you could fall, you could get hurt. You know, the poles are usually slick, and maybe if it's cold out and your tongue gets stuck on it, you won't get off or whatever. So flagpoles can be very hard to measure. So this one, it could be this is easy to measure right here. So this is, let's say that I'm 6 feet tall. I'll give myself a few inches to make myself taller. And let's say my shadow is 8 feet long. And this one could be pretty easy. Let's say this is 18 feet long. But I would be nice if I could measure the flagpoles, okay? The flagpole. And that one is, I don't know, I'm going to call that X, because I don't know how to do that, besides getting a really tall ladder and maybe hurting myself. So there's a way called indirect measurement we can do this, okay? So I want you to look at this really quick, and then we'll talk about how we would do it. And we'll come back to this in a second. If I make a triangle between myself, the end of my shadow, and the ground. That's going to be a right triangle. And this angle right here is going to be formed just by the sun and my body. And then if I make another triangle with the flagpole, so this is me, this is my shadow, this is the flagpole, and then this is the flagpole's shadow. These two triangles are going to be similar because all their angles are going to be the same because the sun is hitting the flagpole and me at the same angle because we're doing this at the same time. So if I know my height, which is 6, and I know my height, which is 6, and I know the flagpole is 8, and I don't know what my height and my shadow, sorry, and I don't know what the flagpole is, but I know the flagpole shadow is 18, I can use something called indirect measurement to figure this out so I don't hurt myself trying to climb up the flagpole. Now, before we do that, though, I'll come back to this problem. You need to copy down this key idea. And these are called proportions. We're going to use proportions to figure this out. Now, you should have seen a lot of these in your 7th grade. So this is a good review of 7th grade. And I want you to take some time and write this down. So a proportion is 2 equal fractions or 2 equal ratios. 2 equal ratios, which are usually just fractions, right? So, and then a really cool thing about that is, so I'm going to say this, pause the video, write all of this stuff down, and then we'll take a look at this here in a second. Okay, so good job. You paused the video, you wrote all this stuff down because I know you wouldn't unpause without having written all this stuff down. And so a couple things I want to talk about, cross products. So if you have like the fraction 1/2, okay, now you know that 2/4 is the same as 1/2. Those are equal to each other, right? So the cool thing about cross products is you can cross multiply and you're going to get the same answer. So if I cross multiply 1 and 4 and I cross multiply 2 and 2, well, 1 times 4 is equal to 4 and 2 times 2 equals 4. So that is always the case. Whenever you have 2 equal fractions or 2 equal ratios in a proportion, then their cross products are always equal. Now, let's say I didn't know, let's say I wasn't sure. So let's say someone came up and said, well, let's say I had 1/2 is equal to 2 over, and I didn't know what it was equal to. Now, obviously, you know it's equal to 4. But let's say I didn't know what that was equal to. So what I could do, and actually let's make this a little more interesting. Let's say that 3/6 is equal to 2. So we won't even go 1/2. So we know these are both equal. So I'm going to know, okay, 3/6 equals 2 over what? So if I didn't know how to do that, I can use cross products to figure that out. And I can just cross multiply. Again, this is stuff you should already know, so this shouldn't be anything huge to new. And so what do I get? When I cross multiply, I get 3 times x, that's just 3x, is equal to 2 times 6, that's 12. And then what I can do is just divide both sides by 3. And then when I do that, when I divide both sides by 3, I get x is equal to 4. Okay? So I can figure out the missing parts of a proportion if I'm missing one of them by using cross products. Now, how could we use this skill to figure out how tall the flagpole is? So let's go back up to the flagpole. Let me give myself some room over here. Let's give myself some room here. Let me do this here. Just give myself some room here. Okay, so what I'm going to do is, so if I'm looking at, let's say I start with myself. Well, I am standing straight up and down at a 90-degree angle to the ground, and the flagpole is standing straight up and down. So that's the corresponding side. This is me. This is me, and this is the flagpole. This is the flagpole right here. Okay? That's going to be equal. That ratio is going to be equal because we know these two triangles are similar because they have the same angles. That ratio is going to be equal to my shadow. So this is my shadow to the flagpole shadow, to the flagpole shadow, which is in this case 18, right? To the flagpole shadow. So this is the flagpole's shadow. So now I have this nice little ratio here. And remember what we just did on cross products. So I can cross multiply. So I can get 8 times x, which is 8x, equals 6 times, what is that? 6 times 18. Well, let's go off to the side. Let's multiply 6 times 18. So 18 times 6. 8 times 6 is 48. Carry the 4. 6 times 1 is 6. Plus 4 more is 10. So we get 108. So I get x, 8x equals 108. And then I could just divide by 8. Both sides. So I'll do a little long division problem here. So we get 108 in here, divide by 8 here. 8 goes into, it won't go into 10, goes into, it won't go into 1, it goes into 10 one time. So that's an 8, and then we subtract, we get a 2. 8 goes into 28, let's see here, 8 times 3 is 24. So 8 times 3 is 24. Bring down 28 minus 24 is 4. Looks like we're going to need a 0 here. Bring down the 0. And then 8 goes into 45 times. So we know the flagpole is going to be x equals 13.5 feet. If I did my math right. Hoping I did do my math right. If I did make a mistake there, please find it. But I think I'm pretty good there. Okay? All right. So your job, ladies and gentlemen, is to use... Let me just get this right here. Your job is I am going to tell you. So I'm telling you right now that these triangles are similar. Okay. So your job is to set up a proportion and then find that x right there. All right. So go ahead and pause the video and see if you can find the value of x. Go. Hey, welcome back. Let's see how you did. Well, if they're similar, then this side right here has to be proportional to this side right here. They're not equal to each other. They're proportion. That's what we line up we're not lining up angles now. We're lining up sides, okay? And then also we know that this side, it corresponds with this side. Again, they're not equal to each other because they're not congruent. They're similar. They're what we call, say, proportional. All right. So now let's go ahead and line those up. So I could say, well, what does 3 corresponds with? It's a little small to see. I'm sorry about that. Well, 21 is equal to, now go back to the little one because you started with the little one. You could start with the big one if you wanted to, but you got to be consistent. So if I start with the little one, I got to go back to the little one. Is equal to 5 over, x. And now I'm just going to solve for x. Okay. So what do we get here? I get 3x because 3 times x is x. I'm doing cross products here. Just doing cross products. Sometimes kids say it looks like a butterfly. I don't know if it does or not. And then I got to do 21 times 5. So off to the side, let me do that really quick. 21 times 5. 5 times 1 is 5. 5 times 2 is 10. So I get 105, right? So I get 3x equals 105. Now, here's a cool little trick. I know 105, not 105, right? I know that 3 is going to go into 105. Do you know how I know that? I know I'm not going to get a remainder because if I add the digits 1 plus 0 plus 5, that equals 1 plus 0 plus 5 is equal to 6. And I know 3 goes into 6, so I know 3 is going to divide 105. So I'm going to divide both sides by 3. So I get 105 divided by 3. 3 goes into 10 3 times. 3 times 3 is 9. Let's see here. That's a 1. 15. 3 goes into 15. 3 times 5 is 15. Get a remainder of 0, so I know x equals 35. Did you get it? Now, you could have found some other things to do. Sometimes kids will say this, well, Mr. Roden, I have a better way. Okay. Well, look, Mr. Roden, 3 times 7 is 21. So I could have just multiplied 5 times 7 and got x. And yes, the problem with that is sometimes it's hard because if, this turned out to be a really nice number, but like up here, it's a little harder with the flagpole problem because, then you have a decimal. So you would have to figure out how many times. And sometimes it's hard to think about multiplying by a decimal. All right. Last problem before I let you guys go is the map problem. This is always a fun problem. The treasure map problem. Okay. So on the treasure map problem, it says the map shows the number of steps you must take to get to the treasure. However, the map is old and the last dimension is unreadable. How many steps does it take to get from the pyramids to the treasure? So we need to know how many steps does it get to here's the treasure right here, and we need to get to how many steps is it right here? So this is missing here, right there, the pyramids to the treasure. So what we're going to do is we're going to write a proportion, okay? So if I'm looking at, let's just pick one of the sides. Now, first of all, I know these are similar because all the angles are equal. And why do I know that? Well, these angles right here are what we call vertical angles, and vertical angles are always equal. I'm going to put these little marks right here mean they're equal, and then that means this angle here has to be equal to this angle here. So that's how I know they're equal to each other, because vertical angles and the other one gets kind of thrown in there for free. So let's write a proportion. So if I choose 300 right here on the big one, what corresponds with 300 on the little one? Well, yeah, it's this x right here. See how it's straight up and down, the right angle, and the x is right there. So I can put 300 over x. Now I got to go back to the big one because I started with the big one. So now I'm going to look at, let me change my color here. Now I'm going to look at 240. Well, what corresponds with 240? Well, yeah, this 80 right here corresponds with 240, right? Kind of the flat horizontal line, in between the vertical angle and the right angle, vertical angle and the right angle. So now we could say that is, okay, so the big one was 240 and the little one was 80. Okay? And so now I'm ready to solve a proportion. But before I solve this proportion, these are pretty big numbers here. So let me reduce a little bit here. Does that sound good? Well, the first thing I can do, I notice I have a 0 and 0. I can divide these by 10. I can divide these by 10 because they both end in a 0. So if I divide, I'm just reducing this fraction right here. I'm just pretending like this doesn't exist for a second, and I'm just going to reduce this fraction. So I'm going to copy down the 300x, and then I'm going to reduce this fraction. Well, if I divide by 10, basically the zeros just cancel out, and I get 24 over 8. Because I like multiplying and dividing by small numbers, not big numbers. Okay. Now 24 and 8, I can divide both of these by 4, but I can also divide it by 8. And that's going to make my answer a lot easier. So again, I'm just ignoring the 300 over x for a second, just because I'm just reducing the right side. So I get 300x over, well, 8 goes into 24 3 times, and 8 divides 8 1 time. Okay? So that makes it a lot easier. This is going to simplify my work a lot more. And then I could just cross multiply, so I get 1 times 300, which is easy, and 3 times x. So I get 3x equals 300. And obviously, we're going to divide both sides by 3. I think you can do that in your head. What's 300 divided by 3? Well, yeah, that's just x equals 100. So we know it's 100 feet from the pyramids to the treasure. Got to get that treasure, money and gold. Maybe there's a crown in there. Maybe there's a ring. Maybe there's a calculator in the treasure. I would think a golden calculator would be the best treasure ever, right? What do you think? What do you think's in that treasure right there? Okay, guys, hopefully this was helpful. And make sure you do your Schoology assignments. It's not going to be Delta Math. It's going to be a Schoology assignment. However, where Miss Horner or Mr. Sansoni puts it in their Schoology site. I put mine in the homework bucket, but this is for all 8th graders. So make sure you do that 5.1 red Schoology assignment. And we're going to say bye now. So we'll see you guys later. Have a wonderful day. Bye.